Circle problems are one of the hardest kind of problems you will encounter on the SAT math section. In this tutorial, we're going to go over every type of circle problem that might pop up on your SAT math test. So if you get a circle question like this, first thing I like to do is draw it out. I make a little coordinate plane. We know that we have an x squared by itself. That means the x coordinate is going to be 0. And we have a y minus 1 squared. This tells us that the y-coordinate is going to be at 1. This is where the center is, and the radius is going to be 7. It's the square root of 49. So let's draw that out. We have our center. That's going to be at 0, 1, and then our radius is going to be 7. So if we draw that out, we can put a point at 0, 1, like right here, and then just draw a circle around it. I'll draw a little line. This is 7. Okay, so awesome. Now the question is asking, if I shift this down 2 units, what is the new equation? So basically you're just going to take this center and you're going to go down 2 units. So I'm going to switch colors. I'm going to go down 1, 2 units. This is not drawn to scale, by the way. This is a horrible drawing. But the point I'm trying to make is the new center here is going to be, it's going to be 0, negative 1. Okay? So that is our new center because we go down 2 units. And then the radius is staying the same, so it's going to be 7. And then now that we have that info, we can basically pick out the equation of the circle. So if we know that the center, the x-coordinate is 0, it's going to have an x squared, so that eliminates these two. And then if we know that the y-coordinate is negative 1, it needs to have a y plus 1 in it. So D is going to be our answer. For this problem, same thing here. I like to draw it out. Let's draw our little coordinate plane. We know that x is going to be negative 4, so it's going to be like somewhere here, and then y is going to be 19, so it's going to be like way up here. The radius is going to be 11, so let's draw that circle out, and then I'm going to label the radius. And then we want to know which of the following is a possible value of a, and we have point a comma b. So what's going on here basically is there's a bunch of points that could be on the circle. That's what they're saying. A and B lies on the circle. So you see I'm drawing all these points. And it's just saying like which one could it possibly be? Like what is the value of A? And basically these points, like if I were to draw like a radius to them, they're all going to be, the radius is all going to be 11. That's kind of the whole idea behind this, right? So what you have to know with this is there's also this, so A is going to be the same as x, okay? That's basically, we're plugging in A for x, and we're just going to plug these values they give us in. So these little answer choices, we're going to plug these in basically for x. And what we're going to do is basically, we have to basically find the value that is less than 121. So x plus 4 squared needs to be less than 121. And the reason for that is because there needs to be a y value in the equation as well, this y minus 19 squared. And if x plus 4 squared is greater than 121, then it's impossible for this equation to equal 121, because remember, when we square something, it can never be negative. So if it's already greater than 121, we can't take away from the value of x plus 4 squared. If that's confusing, just let me know in the comments. But let's just start by plugging in the numbers. So if we plug in a negative 16 plus 4 squared, that's going to be 144. You see how that's not? So let's cross that out. Now let's do negative 14, and then negative 14 plus 4 squared, less than 121. That's going to be 100 is less than 121, and that checks out. So that's how we know that that is our answer. So for this problem, same thing as before, I'm going to draw out the coordinate plane. We know that we have a center at negative 1, 1, and they don't tell us the radius, so I'll just draw a random radius. So we have this point 5, negative 4 that lies on the circle, and it's tangent. So let me draw that out. And a tangent line basically means it's just going to hit the circle at one point and then leave. What you got to know about tangent lines is they're perpendicular to circles. So that means if we draw this radius line out, it's going to be perpendicular. Now we want to know which of these points can lie on the line. So we have to find the equation of line T. We know the slope, so that's the first thing we need to know. The other thing you need to know is the, sorry, I said that wrong. We know a point on the line, we need to find the slope. So we know that the slope is going to be perpendicular to this one. So that means it's going to be the negative reciprocal of whatever this radius slope is. So let's find the slope of the radius. So that's just going to be basically the center, this point, and this point. We're going to take the slope between those 2 points. So that's going to be 1 minus negative 4 over, and then that's going to be negative 1 minus 5. So that'll be 5 over negative 6, which is negative 5, 6. So then now, since it's perpendicular, I'll draw a little arrow. That means the slope of the tangent line, I'll just call that MT, is going to be 6/5. So what we do is we flip it, and then we times it by negative 1. That's what a negative reciprocal is. So then now, let's plug in to our point slope formula for this line over here. So that'll be y minus y1 equals m times x minus x1. So y, we just leave that as y. The point it's right here. This is our point. So that'll be y minus negative 4 or y plus 4 equals 6/5 times x minus 5. And then now all we have to do is just plug in all of the answer choices into this. So I'm doing it mentally right now, and I can tell the answer is going to be C. So that's because if I plug in a 2 for y, so that'll be 2 plus 4 equals 6/5 times 10 minus 5, and then I work that out, that'll be 6 equals 6/5 times 5, 5's cancel, and then 6 is going to be equal to 6. That checks out, and then that's how we know that that is our answer. So with this equation, they're nice enough to give us the equation and draw it out for us. So I don't got to do that this time. So basically what's going on here is we have a new circle, circle B, that we're moving down 6 units and doubling the radius. And then we want to find the new equation. So what we got to do, I like to draw it out. So let's move it down 6 units. The x value stays the same. And we double the radius. So let's just kind of make it look bigger. And then now we need to know the new equation. So we know the center is going to be, it's still negative 2 for x, and then it's going to be negative 6 for y. So then if we write that out, we know that it needs to have an x plus 2 squared plus y plus 6 squared. And then anything that doesn't have that, we can just immediately eliminate. So we can eliminate C, and then we can eliminate D. So it's between A and B. We know that the radius doubles. So that means that the radius is going to be, let me write that out, that'll be 6, which means that this whole equation is going to need to equal 6 squared, which is 36. And that means it's going to be A because this equals 36. It's 4 times 9, which is 36. So this is the hardest problem we've done so far. We have this circle with points A and B, a center C, and they give us the coordinates of point A, and then we want to find the length of AB. They also tell us that ACB is a right angle. So let's draw this out. We're just going to draw a arbitrary circle. So I'm going to draw that out. We have point C. I'm going to label that. And it has coordinates h comma k. So let's keep that in mind. And then now point A is h plus 1 comma k plus 1 square root of 102. So it's basically, it's on the edge of the circle, and it's offset by these values. So it's going to be to the right 1 and then up square root of 102. So that's going to be like 10 point something. So it's going to be like up here, something like that. So let me label that. So that's h plus 1 comma k plus square root 102. Okay. And then they tell us we want to find AB, and they tell us that ACB, they form a right angle. So it's going to be something like this. Maybe not exactly there, but they form a right angle. And then now we want to find AB, so it's like this point connecting the two of them. So if you notice, the light bulb should have gone off in your head by now that this is a right triangle, so we can use Pythagorean theorem. And then the other light bulb that should have gone off is like these are both radiuses of the circle, so they're both going to be the same. So if we know this part right here, then we also know this part, and then we can just do Pythag. So it's pretty easy from there. So then to get this one, we just do the distance formula. So that's going to be the square root of h plus 1 minus h squared plus k plus square root 102 minus k. I went off screen a little bit there, but it says minus k. And then, yeah, let's just work that out. So that'll just be, basically, the variables just cancel. So it's just going to be 1 squared plus square root of 102 squared. So then when we do that, that's going to be 1 plus 102 square root. So that's going to be square root 103. So then now we know this, and then we know this. So then if we do Pythag, a squared plus b squared equals c squared, ab, then I'll put that over here. That's just going to equal the square root of square root 103 squared plus square root 103 squared, and then we just work that out. Remember, if we square a square root, it's just going to be the number on the inside. So that's going to be 103 plus 103 square rooted, which is going to be square root of 206, which, would you look at that? That is answer choice A. Okay, so here's another question where we have a circle with center P, points Q and R lie on the circle, and the radius of the circle is 9 inches. The perimeter is 31. So let's kind of draw this out. We have our circle. Our center is point P, and then we got like two random points. I'll call them Q. Well, that's what they're called, Q and R, and they form a triangle. And then they tell us that the radius is 9 for the circle. So remember, any point going out from the center to the edge, that is going to be a radius. So we know that these are going to be 9. We know that the perimeter of the circle is 31. So then, now it's pretty easy. We just do 31 minus 9 plus 9. And then that's just going to be 31 minus 18, which is just going to be 13. All right, so this next question we got here is dealing with area. So we have this circle A has a radius of 3n, B has a radius of 129n, and then the area of B is how many times the area of A. So it's like a ratio kind of question. And if they ask an area question, it's likely going to be like this because it's going to make you think more. So first thing you got to know is the area of a circle is going to be, it's going to be pi r squared. You should have seen this formula before, but if you haven't, that's what it is. So now I'm going to write the areas of A and B. So if I write A, I'm going to represent its area as A. That's going to be equal to pi times 3n squared. So that's equal to pi times 9n squared. And then I'll just write that as 9 pi n squared. And then same thing with B. This is going to be it's going to be pi times 129n. And all of that squared, and then that's just going to be pi times 129. You got to put that in your calculator, unless you're a genius and you can square it in your head, but I can't. So that's going to be 16,641 n squared, 16,641 n squared, and then I'm just going to rewrite this as 16,641 pi n squared. So now we just need to take the ratio of B to A because we need to find out how much bigger it's going to be area-wise. So B over A, I'll write that right here. That's just going to be this over 9 pi n squared. And then what you'll notice here is like the pi's cancel and then the n's cancel. And then you're just left with dividing these two numbers. So if I do 16,641 divided by 9 in my calculator, that's just going to be 1849, which is going to be D. Alright, so this next one I'm going to go over is, I would say, the hardest circle problem I've seen on any of the SAT practice exams. So if you can get this, I'd say I'm pretty confident you can get any circle question. So the perimeter of an equilateral triangle is 852 centimeters. The three vertices lie on the circle, so they're on the edge. And then the radius is w square root of 3. We got to find w. So basically what's going on here is we have this circle. I'm going to draw it and with the center. And we have a equilateral triangle that lies on the edge of the circle. So it looks something like this. The perimeter is 852. We need to divide that by 3, so I'm going to put that in my calculator. That means each side is going to be 284. So let me write that in. And then now we need to find w. So w square root of 3 is the radius. The radius is basically the center to the edge of the circle. So I'm going to draw these two to form like a little triangle here, and then this is going to be w square root of 3 in here. And then basically what I'm going to do is I'm going to form a right triangle, and then we're going to use that to get our answer. So this looks really bad, so I'm going to draw this down here. So we have this right triangle. Let me draw it out. We have w square root of 3 here, and then we have 284 divided by 2, because we split that little triangle we made in half. So 284 divided by 2, that's going to be 142. And then this angle right here, remember, equilateral triangles have angles of 60. We're kind of splitting that angle in half, so this is going to be 30. And then now, if you notice, it's a right triangle. We know the angle. We know one of the sides. That's all we need. We can just trig it out from here. So basically, we want to find the hypotenuse, and then we're going to set that equal to w square root of 3. So I'm going to set w square root of 3 equal to x. Bear with me here. I'm going to explain why, where x is the hypotenuse, and then we're going to set them equal at the end. So what we'll do is let me go over here. We'll do cosine 30, because we have the adjacent side, equals adjacent over hypotenuse, so 142 over x. Cosine 30, if you know your unit circle, that'll be square root of 3 over 2 equals 142 over x. So then if we solve for x, let's multiply it to the other side. We'll get square root of 3 over 2x equals 142. Now let's just divide it out to the other side. So then x is going to equal 142 times 2 over root 3, which is just going to equal, that'll be 142 times 2. It's going to be 284 over root 3. So then now, all we have to do now, x is the same as w square root of 3. So we just set w square root of 3 equal to 284 over root 3, and then we solve for x. So let's multiply that root 3 out to the other side. That'll give us 3w, because square root of 3 times square root of 3 is just 3, equals 284. And then we divide by 3 on both sides. So w is going to be equal to 284 over 3, and you can enter your answer just like that. Thank you guys for making it all the way to the end of this video. I hope this tutorial on circles helps you guys get a better score on the SAT. If you want to see more content like this, make sure to subscribe and smash that like button down below. It really helps the channel out a lot. I also run a tutoring company called MVP Learners. You can check us out at mvplearners.com. We do online tutoring, so if you need some extra help, just go check that out and we'll be happy to help you.